we got a lot that we want to do tonight. And Linda made a note that the session is being recorded, so that's all good. And Linda, I'm going to ask you, if you will, to please go and fire up the, there's a PowerPoint thing that says 9.8, and we'll begin there.
Already on top of it.
Great. Okay, and so she's going to advance the slide once, and we'll look at this. This is kind of a broad, well, actually, this is the opening salvos. I do want to give you a Pearson update. And by the way, just today in between this, I thought I'm going to give you a really, really good update. And so I went all the way back. I've been arguing with them since the first day of class. I have emails from the first day of class that I've been arguing with them. And yesterday, I got an email finally from some person who said, "Oh, sorry, I haven't gotten back to you, but you know, I've been busy." And but then they said, "And I'll have somebody who knows something contact you." So then I got some of these nonsense emails of saying, "Oh, please explain your problem in words again." And I've done that many, many times. But then I also got an email today from someone who said, "Are you available to talk?" And I said, "Talk? What's that?" And I was very excited. And I told them to call me, not during this class, but call me sometime soon. Now, rest assured, though, that I am compensating through the lectures, so you're not missing out. But what I'm going to do whenever we do get all this resolved, I'm going to say, yeah, and you know, read section 3.5 or whatever that is. Okay. That's the update on that, and I do plan to do just a little bit of Q&A here, so if people have questions, they can ask. Linda, I know you sent me an email about this, and maybe in that space, you know, we can talk about that. We'll see. I am going to, I haven't got it done yet, but I am going to publish the solutions to the county problem, and that's the first thing that I do before I grade them. But then I'll turn and grade them, and then you'll have grades for low stakes assessment number 1 and low stakes assessment number 2. So that's all good things. And we're learning some statistics, and we're getting to practice some of our work, and we're learning some Excel there, but we're also learning valuable skills for whenever we get to these high stakes assessment. And this time through, I expect people to be really good at this by that time. They've stubbed their toes if they're going to stub their toes before that. And I did just post a brand new content contribution, and that includes a video I'm asking you to watch that deals with, and Linda, this will have meaning for you, I suppose. This is the smoking video where they're talking about causation and correlation, and so that's a good time for us to be talking about that. So I signed that video, and then I also gave you a video that actually explained the problem that you're going to solve. And tonight we're going to do some examples that should help you as you're embracing the problem that I've asked you to do. And in fact, okay, so now I'm going to ask, how are you doing? And let's begin with a poll here. And so Linda's already got that. Boy, you know, Linda, I don't say it often enough, but you're really quite remarkable. No, I mean, I'm serious about that. Okay. Hey, I don't want to say I'm okay with that. I mean, I would like for everybody to be great, but okay isn't bad. I mean, at least when I say I'm okay, that means I'm good enough for that day. And no one is, and by the way, we don't know, who's saying these things, so you don't have to worry about that. But I see no one is claiming to be struggling, and that makes me very happy.
And I think we're the only two that haven't responded, so no one is drowning.
Oh, okay, then, all right, so that is excellent. Now, I am going to throw it open for questions, but it's not going to be like forever. I'm just saying, I'm going to, like say, any questions, and then I'll, do a beat of maybe to 5, and if no one asks anything, then we'll just plow ahead. So questions? Okay, so Joshua's got something. Joshua, I don't know if you're speaking, but please speak if you can, or chat if that's what you're doing.
I am here. All right. Saw your email regarding the next assignment. But looking at it, the lessons, you said to watch lesson 16. Are we skipping lessons 14 and 15 for the present moment?
For the present moment. And some of this has to do with what, kind of what I'm having you work on and things like that. And Joshua, even though it might not matter because the damn book has been screwed up, I'm really trying to merge, because there's different orders you can do things, and the videos do it one way and the book does it another. And so I'm trying to hit a sweet spot in between. So that's why we're going there. And in fact, Linda, and now I'm warning Linda of something. Linda, later on this evening, and you might not be aware of this, but I'm going to be asking you to, this thing keeps popping up with this other thing. I'm probably going to have to, log back out and log back in again. But let's, okay, you can still hear me talking, right?
Yeah.
Yep.
Okay, great. I'm just going to talk for a while then. And somewhere along the line, I will log out and log back in. But Linda, I'll probably do that when I'm asking you to do something. Okay.
Okay.
And but Linda, well, first of all, Joshua, did you get your question answered enough?
Yes, you did. You've
Okay,
done a
that's
great
good.
job. Thank you.
So, all right, excellent. And I'm going to pretend there's no one else out there. Linda, if somebody's doing chats or raising their hand, I can't see it right now because I got this thing where they start telling me they're always trying to sell me. Let's see, I got on my screen right now, I have Home Depot, I have McAfee, and I have some kind of news service. So anyway, I will get rid of those eventually. But let's go to the next slide, Linda, and tell me what is there. In fact, what I think I'm going to ask you to do, Linda, is go ahead to. Geez, this is really horrible. Wait, I think I figured out a way to do this. So I'm at least looking at the slides, and I will log back in so I can see you guys. Okay. So questions and answer is over. Opening salvos is over, and now I'm talking about tonight. Okay. Now tonight, some of the things we're going to be doing, and these are videos that you were supposed to have watched dealing with correlations. And these were the two twins that were separated at birth, and then they brought it back together, but they both were volunteer firemen and stuff like that. So you've watched that. So we're going to talk more about correlation and things like that. But Linda, I guess the way we're going to start here is I'm going to ask you to go to the Bears database and help the students find that, because they should be calling us up. And that's somewhere within their Blackboard. And I'm going to log back out and log back in so that this is working. But Linda, I want you to maybe make a scatter plot. Don't worry about the least squares curve line right now, but make a scatter plot of the Bears' weights. And then we're going to go and we're going to talk about male and female bear box plots. I think you're comfortable, I hope so anyway, with doing that while I'm relogging in.
Yeah, that's fine.
All right, so go for it and be talking to the students and leading the discussion, please. And I'm logging out and logging back in.
Okay, so first thing I'm going to do is share my screen for you guys. As soon as that pops up, there we go. So I'm going back to the syllabus tab and scrolling all the way down and stealing the Bears file. So I'll open that up, and Professor Bradley asked me to make a scatter plot, so I will start doing that. Now let's see. We have age, month, sex, head length, head width, neck length, chest, and weight. Okay, so depending on what Professor Bradley likes to do, I believe we'll start with test and weight. So
Yeah,
I'm
let's
going
do,
to,
chest and weight is fine.
yeah, I mean, we've done that before, so why not? And then I'm inserting. I want the one with all the little dots because that is a scatter plot. And there we go.
Now, what you can observe from that, and Michaela, I see you, but what you could, and what I'm going to call on you in a minute, but I'm going to make a comment here. And my comment is, if you look at that graph that Linda created, that scatter plot, and by the way, we watched a video about scatter plots too, but that you can pretty much say that, and I think she said chest was down there as the X. So chest, then, the bigger the chest, the more the bear tends to weigh. And so that's kind of what's going on there, and that's something that you can see from that. And often a scatter plot will really help you figure out that. And again, we're talking about finding lines of best fit, so that matters to us that we say, oh, that's happening. And we're going to see, and this was in the videos, and Michaela, I'm not ignoring you, so please hang in there. Also, we see that if we started talking about, oh, there's kind of a line through there, that would be a positive slope. So we expect there to be a positive correlation. Okay, Michaela, what's up with you?
I just don't have the data because I'm in the net course. I just wondered if you could, after class, maybe put in the data from this class and the last class.
Sure, and in fact, let's see. Yeah, I'm trying to think what I'm going to, I guess, okay, here's what I'm going to do. Yeah, I definitely will do that, okay? And Linda will remind me and make sure that I do that. So yes, we will. But that's how it works. Okay, and so now we've done a scatter plot. And we could do a scatter plot of something else too. We could do, now I don't really know if, oh, now, Linda, this is kind of dumb, but I do dumb things sometimes. We're going to go over and we're going to look at sex. And the sex here is you were either a 1 or 2. And I don't really know, but, you know, they've made a decision. So either they're, and I'm going to call it male and female here. So now I'm going to ask Linda to do a box plot, or not a box plot, but a, what do I want to say? Do a scatter plot of weight and sex.
Okay. So let's see, since those are not next to each other, then I'll have to get a little fancy here.
Fancy is good.
So this goes down to 55. Okay. So I am going to insert a scatter plot. But now I'll need to actually designate what data I'm using. So hold on, there's a way to do this.
Hey, instead of getting fancy, copy that and put it over there where it's close next to the thing. And,
yeah,
and
I guess that works.
That's brute force, but that's okay. And Linda, I know you're smart enough to figure that out, and you will, but let's just do this.
I think there's a way if you hold down Control, then you can select 2 different things.
And that's one really good thing about you guys going to the
You want a scatter plot or a box plot?
Let's do a scatter plot.
Okay, it's not very helpful though.
Well, it's not very helpful, but what I'm really trying to say is, now there is something that you learn from this. You learn that whatever 1s are typically not as heavy as 2s. And I'm going to guess, or actually maybe I'm saying that wrong. I don't know what I'm saying here. It's not very helpful. It doesn't give us any insight. So you see, before we saw that there was a linear relationship, but here we found there is not a linear relationship. Okay, so that is that's good. And Linda, let's do one more. I will let you pick one of those other variables like,
Okay,
yeah, or whatever you want.
we'll do neck and length. Maybe they all just have really long necks. Yeah, I'd say so.
Now, okay, so what does this say? Does this say that the longer their neck, the heavier they are, I guess, right? Or the heavier they are, the longer the neck, the way this, well, it's got X's and Y's, but yes.
Yeah, so I mean, this is the length of the bear and the neck length, or
Okay.
the circumference, or bigger necks for bigger bears.
Okay. All right. So now we've talked some about scatter plots. And now what I would like to do is, and Linda, you might not, well, we're going to do it once. So go back to the PowerPoint slides, please, and I'll guide you a little bit. I'm trying not to get myself in trouble here with my guidance. Okay, go to, it looks like it is slide 5. Now there is a formula, and this formula was shown to you in the in the videos that you watched, but this is called the correlation coefficient, and sometimes this is called the Pearson correlation coefficient. Now, what this says is that to get the correlation coefficient, what we will do is we will add up xi minus x bar all over the standard deviation of the x values times yi minus y bar all over the standard deviation of the y variables. And then we divide this by n minus 1. And that is the correlation coefficient. Now, we're only going to do this calculation once. But, Linda, I'm going to ask you to go back to the bears thing, and that's probably where you are anyway. And wow, did I get lost? No, here I am, I think. Okay, so what we're going to do is we're going to go and we're actually going to calculate this once. Now, and we're only going to do it once, but Linda, when we get that 2, we'll be able to, in fact, find the line of at least a best fit 2. So I liked what you did with chest and waist, and you could probably do away with the sex here, the sex column.
Then I will
You know what
delete
I'm
that.
asking you to do?
Yeah.
Okay, cool. Well, shut up.
Okay, so I'm going to call chest the X column and call Y the weights. So just a little note for myself. Now, first thing I actually need is the means and standard deviations. So I'm going to make myself a little chart here to help organize that. Okay. And then to find these, I'm just going to use my standard Excel functions. So equals average, open my parenthesis, and I'm using all these values. But it did not like how I entered it. Probably because I don't have that extra parenthesis. And then my standard deviation is STDEV. This is a sample because we don't have the data for every single bear there is. And I highlight my data and close the parenthesis. So now I have those 2 values. I can actually copy these formulas over and it'll switch it. So before we were using column H, now we're using column I. And you can kind of see that up here in the formula bar. So I'm doing the same thing for standard deviation. So now I can actually
learn a lot from Linda on this. Go ahead. Okay, so we have that.
Sorry, what?
I said they could learn a lot from you because you're tricky this way. This is good.
Yeah, I'm tricky in a few ways. So next thing I'm going to do is subtract off the mean from all of the X values. So x minus x bar. And I'm just going to do the x's and y's at the same time. So this is going to be y minus y bar. So to get this, what I'm doing is I'm taking my x value, so right here, minus, and my mean is in cell L2, so I'm doing $L, $2, and I press enter. Okay, so I drag that all the way down, and I'll need to move those charts. Or I'll just delete them.
Yeah, I don't think
we don't need those. Okay. There we go. So I'll have to retype in that formula, but that's fine. Okay, so now I can drag that all the way down. And I'm going to do roughly the same thing for y minus y bar by doing equals, taking the y value, minus $M, $2. And then I'll drag that all the way down. Okay. So the next piece of my equation is I need to divide both of those by their respective standard deviations. So I'll call this one x's divided by SD, and this one will be y's divided by SD. So each of these do have a separate standard deviation. So I'm taking equals here, divided by, and now my standard deviation for x is in cell L3. So $L, $3, and I can press enter. Drag that all the way down. And then I'll do the same thing for the y's. So equals, I take the y minus y bar term, and I'm dividing that by the standard deviation for y, which was in cell M3. So $M, $3, and then I'm dragging that down. So my next step in this equation is I'm multiplying those two terms. So I'm just going to call this one multiply. So equals, and I'm taking the cell here and multiplying it by the y's. And then drag that all the way down. So next we need to take the sum of that column. So I'll label this for us. And I'm using the equation equals sum, open my parentheses, and it doesn't matter where you start. So I'm dragging from the bottom up. Close my parenthesis and press enter. So that is my sum. Now I need to divide that by n minus 1. So looking back at our original data, we have, let's see, it goes down to 55. One of those is for the headings, so 54 data points. So if n equals 54, then n minus 1 will be 53. So I'm doing equals, taking that sum, and dividing by 54 minus 1. And I'm putting that in parentheses so it gets done first before the division. So then my correlation coefficient is 0.96.
Now that is a positive 0.96, and one of the things you learned in the video is that the correlation coefficient has to be between -1 and +1, and the closer it is to +1, the closer it is to a perfect fit. The closer it is to a -1, the closer it is to the perfect fit. Now, Linda, it is the moment of truth, because I'm going to ask you to, and there's actually several things up there that will give them this as a function of the data. And I said we were going to do this calculation once. I can't ask you to do this on a test, or I mean, I could, but this calculation, particularly if you're not doing this over Excel, this would take you all term to do that calculation, and so we don't have that. So Linda, I think both Pearson, because it was named after him, and also Correll for correlation is there. C comes before P, I think, and so let's use the correlation Correll. Yeah, that's the correlation coefficient between the two.
Okay, so I'm taking these two columns, close my parentheses, press enter. Oh, it needs the titles.
Really? Okay.
I believe so. So, oh, I have to select them separately. That's what it is.
Here's Linda. I'm going to ask you to do something else right now. And by the way, Linda's really good at this, so she, kind of does some things here. But I'm going to suggest that, Linda, go up there, and we're going to do something a little bit different than what you were doing. You were just starting to type it, and I was remembering what the letters were. But let's pretend we didn't remember that. So go up there and erase everything in your function box up there.
Okay.
Okay, now, I know, Linda, someday I will die and you will teach this class. So anyway, this would be, she's clicking. No, just click the FX and look at it. So change it to all of them. Oh, she's doing a search. Okay.
Yeah, I mean, you can do either one, but if you don't really know what the title is, then you can just search for what you're looking for.
So she'll scroll down to get Correll or whatever it is. And she'll say, oh, that might be correlation. And pause right there. And you see what it tells you underneath there is it tells you how you format that, and it also says what the heck this is. So you say, oh, that looks like that might be it. Well, then you can read and say, is it? So this is the correlation coefficient between the two data sets. So she's going to click OK. And you're going to do one array and the other. Now, one of the things that you learned in the video was it really didn't matter which one was which was X and which was Y. And so we're exploiting that. The correlation is going to be the same. In fact, you could look at the equation and get that. And you see the number is up there, 0.96. Boy, Linda, you really are good. You got exactly that number. So, but you see that did that calculation, and that was really pretty quick. Okay, so say she's saying okay, and that's a faster way to do it. And Linda and I both will let you do that on the homework that I'm asking you, and we're going to do that some more now. Okay. Okay, so let's invent 3 of these things, and here's what I want you to do. And this is practicing stuff that I do ask you about in that other problem. Okay, so do tune into this. It really lines up very well with that. So Linda, my idea here is, and by the way, if you have a better idea, we can do it, but I'm thinking let's do chest and weight, length and weight, and neck and weight, or something like that, like 3 of them, and we'll see which one has the better correlation coefficient. Go ahead.
So we already got chest and weight. So yeah. So we know what we're actually finding. Now we'll do length and weight.
And if you have 365, you ought to be doing this along with her.
And the next one will be neck and weight. Okay. So I'm using my same formula, just Corel. And this was length versus weight. So highlight the length, comma, and then weight was the last column. Close my parenthesis, press enter. So not quite as good a correlation. Then once again, same formula. So now I'm doing neck and weight, comma, and highlight the other one. Close my parenthesis, press enter. So pretty decent.
Okay, so what happens there though is if you were a statistician and you wanted to have only one variable, you'd say, well, I want the best one. And so the best one would be the one with the number that's closest to 1 in absolute value. And so that one it is best. So that's the thing that we would end up doing the regression equation for. Okay, now I'm trying to remember, and maybe Linda remembers, but I think I did ask the students to, or I guess I'm throwing it out there in general. I think I asked you to watch the video that dealt with finding the line of least squares best fit, didn't I?
I'm not sure. Anybody know?
I sort of think I did, but let's not worry about that now. But we did find the correlation coefficient there. Now, Linda, I'm going to ask you, don't throw this away because we might go back here, but I'm going to ask you to go, and I'm trying to have more than one PowerPoint slide thing open, but go back to Blackboard and check on I'm trying to remember what I called it. I think I called it the baseball Pythagorean theorem, the problem.
Okay.
Now, Linda made a good suggestion. She makes a lot of good suggestions. And she suggested that I start posting these there in addition to making videos about them. So I did both this time. So she's opening this up, and I want to show you how the things you've been learning tonight fit in nicely here with this. Okay, so, and just keep advancing it a little bit. We'll look at the words that there's the file. That file is in Blackboard, and Linda, we'll call that up in just a minute to look at something. Okay. And keep going with that's background. That's not the question. But here's some of the questions, okay? One thing I ask you is, the third one down, Linda, it says consider the winning percentages and runs scored first. And then you consider the winning percentages and the runs allowed. Which of these correlations is better? Okay, so with the videos, your readings, and other things, you want to come up with that idea. And then in the next one, the fourth one down, I'm asking you to compare that with Bill James' formula that I tell you what it is there. And you can say which correlation is stronger. So you see, that's really a lot of what we did there. Now, at the top, though, I do ask you, very first thing, I asked you to construct a histogram showing average runs scored by major league teams. Is it skewed or symmetric or what? Now, Linda, we're going to look at bears, though. So we're going to go look at that. And then the other thing is, I say construct a side-by-side box plot showing the average runs scored by an American League teams versus the National League teams. And does there seem to be a difference? So Linda, we're going to do analogy, Linda and my students, we're going to do analogies of these, but we're going to go back and we're doing these relative to bears. I'm just trying to show you that we really are covering stuff that's really good. So now we're going back to bears again. And Linda, let's do a histogram of the weights of the bears.
Okay.
And we're just reminding students how we do that.
So I am highlighting the weights. And then we're going to go under Insert and hit the one that looks like a, let's see. Yeah, I think that one works.
Well, that's a not.
Okay.
There's one that looks like a histogram or statistics or something. I don't know. There it is.
Yeah,
well,
that's what I thought, but
this looks different.
It does look different, doesn't it? Let's look under recommended.
This is not. I don't know what happened here. Looks like this was not 365.
It should be. Let's see.
You
Maybe
opened my
it's because
file.
I included the title or something. Yeah.
Okay, so
this is copy of bears.
Okay, so there's a histogram thing there somewhere.
I mean, there should be.
Yeah.
We just used it like the other day.
If you guys are just using
That's
straight
so weird.
up.
I'm just looking over everything now.
Here's my guess. Well, you said this was 365 though?
It should be.
Yeah, but look what it says up there. It says compatibility mode XL. So I'm thinking this is probably whatever thing. Okay, all right, let's do something different though. Tell you what, let's try this. And we're backing out. But guys, I want to show you how to do this on 365 because I think it's cleaner. So Linda, don't throw this away, but we're going to reopen the bears thing, but we're going to open it from 365. Do you understand what I'm asking you to do?
Yeah, I'll try it again.
But you see it's opening in XL 97, not 365.
Where does it say 97?
When you were back on the screen with the program names and stuff, it was showing me that.
I mean, this is the same version of Excel that I've always used, so.
Okay. All right, well, we're not going to do that. Let's do something else, though, just because that's, yeah. Okay, Pauline is saying resave it as, that's kind of what I was trying to think about, but
Okay.
See if you can save it as a different version of Excel 365. Save as.
Yeah. Probably just Excel workbook.
I'm not sure. 365 isn't listed there, is it?
I don't see it.
Let's try that.
Why not?
Oh, that was a good suggestion. Thank you. Give it a go.
Okay. Still not seeing any histogram up there.
Okay. Well, we're going to figure that out, but not right now. We're not going to burn any more time doing that. Pauline says you still have to close and reopen.
Okay. And I will close it and reopen. And maybe now it'll be good. There we go.
Pauline, thank you.
Now I see a histogram.
Now, you don't get any extra credit, but what you do get, Pauline, is my undying gratitude, okay?
Pauline, you get extra credit with me. You're my favorite now.
Okay. Hey, how's this skewed? Let's do a poll. How's this skewed? So either it's going to be symmetric, left or right, I guess, Linda.
Okay, give me 1 second.
And then you guys be thinking about that and give us an answer.
I'll bring it back up on the screen in case you forgot.
Well, okay, so I guess I'm feeling pretty good about that. Again, the skew is which way that tail goes. And so the answer for this one should have been right. Now, don't worry if you missed it, because that's okay, because you learned something and you won't miss again. So that's all good. Making mistakes is fine. I make them many times a day. Okay, that's good. Now, Linda, that we found this, that means we can do the side-by-side box plots, which I also was asking you to do about national life. Oh, what does Jessica ask? What does the tail mean? Linda, you got the pointer there, so can you talk about that?
Yeah, so if you kind of look at the shape of the overall histogram, then the tail would almost be like, imagine this is a mouse. So that would be it's behind, and then you have the tail right here where it gets really, really low. So if it was more symmetric, then we'd see the high point in the middle or even off to the sides, but it would mirror each other where the middle line would be symmetric on both sides.
Okay.
So here we're just looking for where is the low point.
And now what we're going to do is we're going to do box plots about 1 bears and 2 bears. And I don't know who is males and who is females, but we're going to do 1 and 2 side by side. And in the other problem, it's going to be National League and American League. So go ahead, Linda, please.
Okay, so we are making a box plot. So just with sex? Or what other variable?
And weight.
Okay. So then actually what I want to do, I believe, is probably, no, I think I can do that just fine. So I've highlighted the sexes. Now I'm hitting control and highlighting the weights. So I'm inserting a box plot. So I'm looking under the histogram. Okay. That doesn't look right. Let's see here.
You know what I think I would do? Now, I realize this is brute force, but I would make 2 separate data sets and do it that way. So one would be one data set, and she's probably going to have to sort those and do some other things. So this is good. It's good review.
Yeah, so I'm highlighting everything. That way the data doesn't get mixed up. And I am sorting it custom. So I want to sort by the sex. And smallest to largest is fine. Really, as long as they're separated, then I'm good. So now I am copying all the ones. So Control C is what I just hit. And then I'll actually go down here. And then Control V. No, didn't like that. It may still have to be highlighted for me to do that.
I think it does, yeah.
Okay, let's try that one more time. Beautiful. And then I'll get weight 2. And that is all these. So hold on, that went a little bit too high up. So copy.
Isn't there a bear down there at the end or something, or what's that there?
I think it's just odd formula things that were typed in.
Oh, okay. All right, but we need that last bear, right? Yeah.
Yeah, I really don't know.
Row 55 is a bear, right?
I think it's just 54. Because over here we had, no, yeah, that should be a bear.
That's a bear, but delete that bear because I mean we're just talking about how to do it.
Okay.
Delete that row because we haven't figured that out yet. Yeah.
Yeah, if we really cared about it, then we could go under Blackboard and figure out what it was, but nobody cares about that bear.
You know, actually, somebody did care about bears because they have this data set. But anyway, yeah. Okay, so keep going.
Okay, so I'm highlighting the data, and now I'll try to insert that box plot. There we go.
There you go.
Yeah, so here we have series 1, and there is series 2. So I'm assuming this is the males and this is the females.
And you can maybe draw some conclusions from that. Let's see. The median is about the same, but the variability is a lot less with the female bears, it looks like. So
it's also a lot lower.
Yeah. Okay, so you see we've done the histogram, we've done the, you know, we sorted them. I think that's a good kind of thing. Linda, let's go back to probably the first PowerPoint slide, and let's look at the outline of what we were going to talk about, because I think we've talked about some good things, but let's see.
Okay.
Okay, oh, this is the wrong one, though. That's not the PowerPoint.
Okay.
You want the other one.
That's fine.
That's
I'll
the
bring
one
it up
that
on Blackboard.
video that you guys are to do a problem with. And we can talk some more about that on, I don't know, whenever it is when we get together again. Okay, we did all of that. Okay, so we talked about correlation coefficients. Before we talk about spurious correlations, though, let's open up that baseball file. And Michaela, you do have the baseball file because I put that there. Okay. I don't know if she's still here, but anyway, she does have it.
I'm still
So
here.
Linda, go get the
Actually, there's no
baseball file
baseball.
from the syllabus tab, and we're going to do a correlation there. And we'll talk a little bit about the data. So just throw the data up as an Excel spreadsheet to start with.
I actually don't have the Bears data or the baseball one.
Well, I could have sworn I put the baseball one there. I mean, I'm not disagreeing with, well, I'm just saying, oh, that must have been a vivid dream. Okay, so Linda's getting the baseball thing up soon.
Yep, just working on sharing my screen. Okay. So let's see.
I really wish you all were just one class. That would make this whole thing simpler, but anyway. Okay, so we'll be looking at the baseball data. All right, now, Linda, we're talking about the top row there. So I said we had teams, okay? We have,
okay.
Let's see, we have a league, and that's an important thing for you guys to do. Games, and then you got the wins and losses, and the win-loss percentages, and that's just an equation. You got the streaks. But then runs means runs scored. Okay, so I'm going to ask, and Linda, we're going to do a poll. And again, if you don't know about baseball, maybe Linda will have a, you know, don't know about baseball item. We're going to say, what should be the correlation between runs scored and winning percentage? And the question you're asking is, if I score more runs, would I plan to win more games? And let's see what happens there.
So what do you want me to make the options?
The options are going to be positive, negative, or don't know.
Okay.
So we're talking about the correlation between runs scored and that. So you guys are going to be voting, and again, play the game. I mean, it's fine because you can learn something from playing the game. So she's going to throw that up, and okay. Okay, now this is kind of a, for me, I find it sad, but it's not because anything that is sad. But what happens is baseball as a sport is not as popular with young people as it was when I was a kid. And the other thing that happens is we have an increasingly diverse society. And for example, one of my best friends in the math department, um, he likes cricket and he knows about cricket, but he doesn't know about baseball much and things like that. So, not knowing what baseball is, you may want to ask some questions as you're doing this problem, but I don't know. But that's the number of points you score. And so let's just look at this. Some people, I guess the majority still say positive, and it is positive because the more points you score, the more games you'll tend to win. And Linda's going to check that, and let's see how that is.
Okay.
So she's doing a correlation.
So what am I doing? Correlations?
Right, runs and percentages.
Okay. So runs would be this column, and percentages, so right here.
Okay. All right, so you see that's a positive number. That means the more runs you score, the more often you tend to win. Now that's about offense because you're scoring points. And by the way, I mean, this could be a soccer thing, except the numbers would be a lot lower. But the more goals you score in a soccer game, the better you do. Okay, now we're going to look about runs allowed. Now that is a bad thing if you're giving up a bunch of runs. And so Linda, we're going to ask the question again. It's the same poll I think you were doing before. But we're going to poll and ask people, what do they think this is going to be? It's the same poll. So, can you just erase that, or do you have to type it again?
I gotta type it again.
I'm sorry.
Okay.
So if you don't know baseball, think about soccer. The more goals you give up, what's it going to do to your winning percentage? And so people are voting here. And yeah, you see, the more goals you give up, that's going to hurt your winning percentage. That means it's a negative. Now, Linda's going to do two things. She's going to calculate the correlation coefficient, and then she's also going to do a little scatter plot. And you see, you can do these things very quickly in Excel.
So that is win-loss and runs allowed?
Yep.
There we go. And now we're going to do a scatter plot.
Mm-hmm.
Okay. So what I'm doing is I clicked on the column for F. Now I'm holding down Control and clicking on the column for I. So I've released Control, and now I'm getting my scatter plot. There it is.
Okay, so you can see it does do a downward slope. Now I'm going to ask you guys a question. Look back at those two numbers, 0.729 and minus 0.85. And Linda, the question is, which of those two is a better fit? And you could say top or bottom. Which one is the best fit of the data? That's the question, and it's going to be the top or the bottom. And again, please play, because I'm trying to, Linda and I both are trying to help you with this, problem you're going to be solving soon. Okay. Does anybody who said bottom, and by the way, that's the correct answer, so I'm not asking you to embarrass yourself. Does anybody from the class who picked bottom want to explain why they knew it was bottom? Joshua, good for you. And I appreciate this, just because Linda gets exhausted. I need to give her a break every so often. So yes, Josh.
No problem. Yeah, I chose that one because the value was closer to -1 as opposed to 0, whereas the other one is further from 1.
That's right, exactly. And they did cover this in the video, but that's an important thing for you guys to know. And damn it, I asked you a question very much like this. Okay. In fact, I guess I had the data. That might actually be the question I asked you. I'm not really sure. Okay. So anyway, we did this. Okay. Now, Linda, let's jump back to. I am watching the time for you guys, but we got 15 more minutes of learning that we're going to do yet. Now, Linda, I think this would be. Let's go back to the original pile of slides that we started doing.
You got it.
Okay, now the video I'm asking you to watch has to do with correlations and causation. So you haven't watched that yet, but you do definitely want to watch that. And what that really tells you is just because two things are correlated doesn't mean one causes the other. I will give you a very real example. One of the things that Cheryl Martin does is she keeps statistics on the Learning Commons. And she has people that she calls frequent flyers. And the students who show up there 10 or more times, she shows that they get better grades on the whole and on the average. And in my heart, I do strongly feel that that is in part because they went to the Learning Commons. But that does not prove that that's what caused it. You might just say, oh, those are the students who come to the college and they have to hang out somewhere in between classes, so they go in there, but they're good students or something. So that doesn't prove it. And in fact, Linda, I'm going to ask you, if you don't mind, to find the spurious correlations. And if you throw up some of those, I will read them and we'll talk about them. But what you see is there are things, and we call these lurking variables, that sometimes cause different results. And so, but these are just showing you how that does not imply causation. So she's going to go to spurious correlations. And okay, so she's got one there. I'll just read this. Okay. So if we look at U.S. spending on science, space, and technology, and that's the red curve, and the black curve is suicides by hanging, strangulation, and suffocation, we see that those do tend to track. And if Linda were to point up there, the correlation coefficient there would be 99.79. Those track very well. But I will tell you that those really don't have, one doesn't cause the other. Let's scroll down and look at another one. I actually like this one. The number of people who drowned by falling in a pool correlates with films Nicolas Cage appeared in. And so if you look at that, now that's not an incredible correlation, but also it's not too bad. It's the 66.6 kind of thing. But you kind of say people are not drowning in pools because Nicolas Cage is making films.
Maybe it's what motivates them.
Well, could be. Let's see if there's another one down there. Okay,
Now
this
one might have some causation.
Okay, go ahead and speak to that one, Linda. Go ahead.
So we're doing per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. But if you think of it as they ate enough cheese where now they become so overweight that they just get tangled in their bed sheets, then, I mean, it might make sense.
Yeah. Anyway, watch the video because that's an important thing, and I ask you a question about that. Now, I know some people have been leaving, and they probably thought that this was the end, but not really. We're going to go back then, and Linda, go back to that formula page again.
Okay.
when I say formula page, I'm talking about, yeah, the raw notes. And we got a page that there is a formula.
Yep, I gotcha.
Okay. Okay, now, in addition to the correlation coefficient and what that means, you can always find the equation of the least squares regression line. And so what you do is you're drawing the best line that you can through those data points. And in the video that, and I am going to double check, but I think I asked you to watch the video, that shows that this is called the least squares criteria. So you see in that equation there is, and Linda may point at it. I don't know if she can point with her thing, with the pointer, but it's y hat is equal to b1x plus b0. This is like you studied in your maths. This is y equals mx plus b. Now the m is the slope, and you might say, I don't see an m. Well, I don't either, but b1 is sitting where m is. So that's the slope of this line, and the y-intercept is b0. Now, so you see you come up with this based on the data, and y hat is the predicted value, and it's based on those things. Now there are formulas here, and the first formula says B1 is equal to R. That's the correlation coefficient. You would have had to do all that calculation, and this is times, and that is S sub, my eyes aren't good, but I think that's S sub Y over S sub X, is the slope, and B0, underneath that, is found by just solving the Y bar minus B X bar. Now, we could do these calculations, and I've taught classes where we actually did this, but we're going to talk about finding this line of best fit. Now, the interesting question we're going to talk about some next time is it good enough to use? And we're also going to talk next time a little bit about R squared. But Linda, what I would like for you to do is go back to the Bears spreadsheet, please.
Okay.
And Linda, when I don't say please, it's just because I'm not paying attention, but please go there.
Yeah, it's implied.
Okay.
Okay, so we're back to Bears.
Back Bears, and scroll up there because I think you still got the standard deviation. Yes, you do. Good for you. Okay. Now, so what we're going to do is we're going to find out what is the line of best fit for chest. Oh, wait, which one of those was best? Yeah, chest versus weight. Okay. And there's different ways you can do this, and Linda just making some notes there, but it's important for you to make note of this, not on this assignment that I'm asking you to do, but on a future assignment, maybe on a test someday, ask you to do that. So the function is called slope.
Okay, so this is B1.
And that's the slope. Yeah.
Mm-hmm. So now we actually need to decide which one is Y and which one is X. Lucky for us, we already did that. Comma. That way it switched the data set. And now we're highlighting known X's. And close my parenthesis.
Now, what that means is for every, let's see, this was weight versus, was that chest? Yeah. Okay, so for every inch, I guess those are inches, for every inch, I don't know, maybe they're centimeters or something. Nah, they're probably, I know what my waist is, so I don't.
We'll go with inches.
Those are probably inches, yeah. But anyway, for every inch, the bear tends to increase by 12.5 pounds. And now she's going to find the y-intercept. And that's just called something like intercept. And since I don't remember, maybe we'll look it up.
Yeah, I'm pretty sure it is. Yep, and it even says in the little description underneath my pointer here, calculates the point at which a line will intersect the y-axis by using a best fit regression line. So we're good. So I'm highlighting the weights, comma, and I'll highlight the chest. Close my parenthesis and enter.
So that means what we have here is y equals mx plus b. And now that is a negative number. And so that means it's probably not physically significant, but that is the line of best fit for that data. And in fact, we could use that. And why don't we pick a chest there? And let's pick a chest that we have. And I'm going to pick a chest of 48. Let's see what the equation predicts for a bear with 48. So Linda's using that equation to calculate that. So if the chest is 48, what does our regression line predict it is?
So I am doing equals. First, we are multiplying by B1. And then we are adding B sub 0.
So that says 337 was the predicted, and that was 48. So there's a bear over here that's 48. And you see they didn't hit that exactly, but it's the best line. And so you talk about the prediction. And sometimes I would ask a question like, is the prediction, which is what Linda just calculated, above or below that? It's below. And that means on the average, this is kind of a heavier bear that was sitting there than what was predicted by the regression line. Now, Linda, let's go back to the formula thing, and I'm going to make one more comment here.
Okay.
I'm going to do one more thing. I am watching the time, but this will fit. There's a concept on the right-hand side of Linda's slide that's called the coefficient of determination. And this is called capital R squared. Now we're going to go through there because this is kind of, it's sort of cool. Capital R squared is equal to the explained variation, and that means explained by the regression line divided by the total variation. And so that means this is actually the fraction or the percentage of the variability that's explained by the regression equation. And if I go all the way to the bottom line there, Linda, on that panel, it's also equal to, and this is only true if you're doing linear things, but we're mostly doing linear things in this class. So that's equal to lowercase r squared. And you might say, why is it called capital R squared? And that's a math history thing, and we're not going to talk about that. But it is this. So, Linda, we're going to go back to theirs.
All right.
And we're going to compute R squared for this batch of bears. And R squared, and we're using the chest and weight thing. Okay, so R squared. So we're just going to take that number and square it.
Clicking on there. I hit Shift and the number 6 to get the caret, and I'm squaring it.
Okay, now what that says is this is really a pretty wonderful regression line because this explains 92.5% of the variability there. That means there's only 7.5% that's sitting out there that is left to other things. And it might have to do with the health of the bear. It might have to do with, all kinds of issues. But it's not, but the regression line really explains it pretty much. It's tightly tied to the size of the chest. Okay. We're doing quite a bit of stuff here, okay? Everybody, hang in there. Don't let yourself get stressed out. Breathe. Linda's there to help you. I'm there to help you. I'm going to be there to help you at 7:30. Tom Topol is there to help you. Cheryl Martin's, whatever you call it, the math assistance area is there 71 hours a week. And so you can get a lot of help. And there's been a whole bunch of students like you who have studied with Linda and me, and many of them are very happy today that they did that. And so this can happen for you too. So don't get spooked. But we are doing a lot, and it's not trivial stuff. I think we're doing some real statistics. And next time we're going to do some more. Okay, Linda, anything else you want to add?
No, I think that about covers it.
Okay, then I guess it is time for me to say, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and each other. And I have office hours in like 15 minutes. Take care.